Hey guys, welcome to 14.4a. We're going to learn how to solve trigonometric equations in section 14.4. So make sure you have a note sheet out where you can put the section, the date, and the I can statement, and then resume the video as soon as you're ready. All right, so we're going to look at solving basic trigonometric equations, but before we do that, we need to talk about the different possibilities for solutions. And there's three possibilities here. One possibility is that you might have a single solution, and that single solution has to fall within the allowable range for the inverse trig function that you will use when you solve the equation. The second solution is that we might have a limited number of solutions based on the unit circle itself. So we might allow all solutions that fall on the unit circle, in other words, all solutions between 0 and 2 pi, not including 2 pi. The third possibility is that we might allow infinite numbers of solutions. And we saw when we started our last section that anytime you're taking an inverse of a trig function, you could have infinitely many angles that would result in that side value. So there are infinite solution possibilities as well. If we look at this simple example, 2 cosine theta plus root 3 equals 0, and we wanted to solve this, the first thing we would do is subtract root 3 from both sides, and then divide by 2. And then we'll take the cosine inverse to get rid of cosine and get theta by itself. And here's where we need to think about what type of solution the problem's asking us for. If we're only asked for one solution within the allowable range, cosine's allowable range is quadrants 1 and 2. The only place that we would end up with a value of negative root 3 over 2 for cosine would be at the angle 5 pi over 6. If we're asked for limited solutions, though, there's actually two places on the unit circle where when we take the cosine, we get negative root 3 over 2. So there, the answer would be 5 pi over 6 and 7 pi over 6. And then finally, we could have all solutions. And all solutions basically means we have to account for the fact that we can circle around the unit circle infinitely many times from any given solution. We can circle in both directions. So for example, we typically express this as 5 pi over 6 plus 2 pi k. And that's because the unit circle has a length of 2 pi. So a circle of it is 2 pi, and k just represents any integer. So for example, if k is 6, it means we circled the unit circle 6 times to get our angle, and the cosine of that angle would still be negative root 3 over 2. So we would need to express both angles plus 2 pi k to account for all the circles. And obviously if k is a negative integer, that just reflects the fact that you're circling the unit circle in the opposite direction. So there's three different solution types that we need to account for here. So let's do a slightly more complicated example. Let's see if we can solve the equation cosine cubed of theta equals cosine theta. And we want to find the general solutions, which means the infinite variety, the allowable solutions, which means the single solution or solutions, and the solutions on the unit circle interval. So in this case, we're going to try to find all three types. So the first thing that I would do if I wanted to solve this problem is I'd probably set it equal to 0 so I can factor. So I'm going to say cosine cubed theta minus cosine theta equals 0. Now I can factor this, which allows me to use the zero product property in order to solve it. So cosine theta multiplied by cosine squared theta minus 1 equals 0. So now we can split these up and solve them separately. So we know that cosine theta equals 0, and we also know that cosine squared theta equals 1, if we just set it equal to 0 and add 1. So then for the left side here, this tells us that theta equals the cosine inverse of 0. And on the right side, theta equals, or I guess I should take the square root first here. So we'll say cosine theta equals the square root of 1. The square root of 1 is plus or minus 1. And then we'll take the cosine inverse. So cosine inverse plus or minus 1. So now let's think a bit about our solutions. And I'm going to start with the solutions on the unit circle, or I guess first we'll start with the solutions on the unit circle first. So cosine inverse of 0 occurs in two different angles. So theta could be pi over 2 or 3 pi over 2. And cosine inverse of positive or negative 1 also occurs in two places. Theta can be 0 or pi. Notice that theta can't be 2 pi because 2 pi is not included in our unit circle interval because it would be duplicative with 0. So this right here would be our answer for the solutions on the given interval. Now typically we're going to write these in order. So we would write them as theta equals 0, comma pi over 2, comma pi, comma 3 pi over 2. So this would be our solutions on the interval. Now, in terms of our allowable solutions, we can only select solutions within the allowable quadrants, which for cosine are quadrants 1 and 2. So our allowable solutions in this case would be pi over 2, as well as 0 and pi, but not 3 pi over 2. So those would be our three allowable solutions. And then finally, we want to think about our general solutions, in other words, the infinite varieties. And so for our general solutions, we can think about this as theta equals 0 plus 2 pi k, and pi over 2 plus 2 pi k, and pi plus 2 pi k, as well as 3 pi over 2 plus 2 pi k. And that's valid, but it's not a very condensed way of expressing this, because if you think about these 4 points on the unit circle, so if I draw in our unit circle here, these 4 points occur at 0, pi over 2, pi, and 3 pi over 2. So basically each point occurs at a quarter turn around the unit circle. So I could instead of having each one and then it's like 2 pi k after that, I could actually just combine all of this into, starting at the beginning at 0 plus pi over 2k. In other words, because pi over 2 represents a quarter turn, and so every time we increase by 1 on our integer count, we would just do a quarter turn around the unit circle. And we could just do that infinitely many times, and we would cover all the same outcomes that are covered in our list here of 4 parts, but instead we would just have one of them. And we could even better, because we don't need to write 0 at all, we could just write this as pi over 2k. And that would give us the same answer. So it's a much more simplified version than writing it all the way through. So just to make it really clear which solution is which, I'll color code this. So our general solutions are green, our allowable solutions are red, and our solutions on the given interval are the ones boxed in blue. So let's look at one more example of this so that you can see this again. So we're going to look at the equation tangent theta minus square root 3 minus 4 tangent theta equals 0. And again, we're going to think about this in terms of all 3 possibilities here. So the first thing that I would probably do here is add square root 3 to both sides. So we have tangent theta minus 4 tangent theta equals root 3. We can obviously combine our like terms here to get negative 3 tangent theta equals root 3. And then divide by negative 3. So tangent theta equals negative root 3 over 3. And then if we take the tangent inverse of this, this looks weird because we are in a position here where we're already rationalized, but we probably want to actually unrationalize this so we can split this up into sines and cosines. So it's probably easier to think about this as the tangent inverse of negative 1 over root 3. Because then if you wanted to, you could think about this as the tangent inverse of negative 1/2 over root 3 over 2. And tangent is sine over cosine. So really we're looking for a place on the unit circle where we have a negative, or we have sine is 1/2, cosine is root 3 over 2. And that occurs in two places on the unit circle. So in terms of our solutions on the given interval, we can think about that as that basically occurs at theta equals 5 pi over 6 as well as 11 pi over 6. And this again is why we practice the unit circle so much, so you get good at thinking about these things backwards. Basically, we have to pick the two places where tangent is negative and our reference angle is such that sine is 1/2 and cosine is root 3 over 2. So these would be the two places on the unit circle. Now, in terms of the allowable range for tangent inverse is allowable between negative pi over 2 and pi over 2, if you remember that discussion that we had. Neither of those fit within that range. However, negative pi over 6 is the same thing as 11 pi over 6, but it is within the allowable range. And then in terms of our general solutions are going to be at 5 pi over 6. Now, remember that tangent has a period of pi instead of 2 pi, so we would add pi k rather than 2 pi k. So 5 pi over 6 plus pi k and 11 pi over 6 plus pi k. But we can simplify this even further, because if you think about it, 5 pi over 6 plus pi k, if k is 1, then you would do 5 pi over 6 plus pi, which is just 11 pi over 6. So this is completely redundant, because it's actually already included within the 5 pi over 6 plus pi k part of this. So our general solution case would actually just be this one, 5 pi over 6 plus pi k, because we don't even need to list the other one at all. So these are a couple examples of how you're going to solve a trigonometric equation. As you're doing these problems in your homework, just make sure you're checking which type of solution or solutions they're asking for, and make sure you're responding to that question. So that brings us to the end of the video. Good luck on the homework, and let me know if you have any questions.